Here's the hypothetical. Right now, this instant, every drop of liquid water on Earth becomes carbonated. We're talking seltzer level, about 3 grams of dissolved CO2 per liter. The oceans, the lakes, the reservoirs, the bottle of water on your desk, the toilet tank, the puddle in the parking lot, all of it in the same moment gains the same gentle fizz as a fresh can of LaCroix. And as a bonus, it all takes on the faint taste of grapefruit. There is one exception. The water inside any living creature is unaffected. Your blood doesn't fizz. The fish don't pop. Animals, plants, every cell on Earth is fine internally. But the moment that water leaves a body or is anywhere outside one, it starts bubbling. So, can humanity survive this? Let's walk through what actually happens. In the first few seconds, the world looks delightful. Lakes start to fizz pleasantly. Ocean waves come in foamier than usual. A glass of water on your kitchen counter becomes a glass of sparkling water. You take a sip. Hey, that's pretty refreshing. Faint grapefruit. The internet immediately fills with people calling this the best apocalypse ever. It is not the best apocalypse ever. Here's the math. There are roughly 1.4 sextillion liters of liquid water on Earth. Seltzer holds about 3 grams of CO2 per liter. Multiply those together and you get something like 4 quadrillion tons of carbon dioxide. For comparison, the entire atmosphere of Earth contains about 5 quadrillion tons of stuff total. So all of a sudden, we have nearly as much CO2 hiding in the oceans as there is air above them, and it's all trying to come out. Now, all of it doesn't come out at once. CO2 is more soluble in cold water than warm water, and most of the ocean is very cold. Deep ocean is locked under enormous pressure, which also keeps gas dissolved. So a huge fraction of that carbon dioxide stays right where it is, at least at first. The fizzing you see at the surface is just the top layer reaching equilibrium with the air. But that top layer is enough. Within minutes, the partial pressure of CO2 in the atmosphere shoots up. By the time the oceans and the atmosphere find their new balance, the air is somewhere between 5 and 10% CO2. That might not sound like much, it is a huge deal. Normal air is about 0.04% CO2. At 1%, you start feeling drowsy. At 4%, you have trouble breathing and your judgment starts to go. At 7%, you lose consciousness in a few minutes. At 10%, you have maybe a minute. So the very thing humans are breathing in the first hour after the change is now somewhere between dangerous and lethal. And here's the thing about carbon dioxide. It's heavier than air. It sinks. It pools in low places, valleys, basements, coastal flats. If you live near the ocean, the air just above the water is going to be a thick blanket of CO2 rolling inland like an invisible tide. This has actually happened before in a tiny version. In 1986, a lake in Cameroon called Lake Nyos suddenly burped out a cloud of carbon dioxide that killed every person and animal within 25 kilometers in a single night. Now imagine that, but coming off every ocean and lake on the planet at once. People in coastal cities suffocate first. Then the fog rolls inland. Anyone in a basement, a subway, a parking garage, the lower floors of a building just stops breathing without ever knowing why. Birds drop out of the sky. The lights stay on. The cars still drive. The internet still works for a few hours, but the air itself has become poison everywhere except mountain peaks. The oceans are dying at the same time. Adding carbonation to water lowers its pH. That's just chemistry. The shells of corals, oysters, plankton, sea urchins, almost every marine invertebrate are built from calcium carbonate. Calcium carbonate dissolves in acid. Within hours, the foundation of the ocean food chain is corroding. Reefs start to crumble. The plankton that produces half the oxygen on Earth begins to die. Fish suffocate from a different angle. They breathe by pulling water across their gills to extract dissolved oxygen. Suddenly, the water they're pulling in is loaded with CO2, which displaces oxygen and acidifies their gills. Most fish die in the first day. The carcasses float to the surface in numbers that turn whole coastlines into a uniform layer of dead fish. And then comes a slower disaster. All that CO2 in the air is the most potent greenhouse gas accelerator we've ever experienced. Climate scientists were already worried about a runaway greenhouse if Earth's CO2 doubled. This event multiplies it by 100 or more. Heat starts to climb. The remaining oceans warm. Warm water releases even more CO2. More CO2 means more heat. More heat means more release. It's the runaway loop the planet has narrowly avoided for 4 billion years, kicked off in a single afternoon. Within months, surface temperatures climb past anything mammals can survive. Within a few years, the oceans begin to boil at the edges. Earth is on its way to becoming Venus. Not metaphorical Venus, actual Venus. A planet so hot the surface glows. So, can humanity survive? The honest answer is almost certainly no. Not on the surface. The atmosphere becomes toxic in hours. Anyone caught outside without a sealed CO2 scrubber is dead in a day. The food chain collapses inside a year. Even with perfect prep and perfect global cooperation, you'd need a sealed bunker with its own oxygen supply, its own food, and an indefinite lifespan. Possibly thousands of years, because the CO2 isn't going anywhere. A few thousand humans might make it underground. Submarine crews could live a while. The International Space Station could host its crew for a year, give or take. Some Antarctic research stations could last a winter. But these are pockets. Civilization is gone. What about leaving the planet, the moon, Mars, anywhere else? People romanticize this option. The reality is that we cannot currently keep a single human alive on Mars for a year without resupply. Building a self-sufficient off-world colony for a meaningful population is not something humans can do in any short time frame. Maybe with a few decades and global focus and tremendous luck, not with a few months. So humanity as a civilization almost certainly does not survive a carbonated Earth. We'd be reduced to a few hundred or few thousand bunker dwellers, slowly rationing oxygen while the world above them turned into a fizzing toxic greenhouse with no way back. But here's what I keep thinking about. For the first hour before the air got bad, the oceans would have looked beautiful. White foam rolling endlessly in, lakes shimmering with rising bubbles, glaciers softly hissing, every river and stream gently sparkling its way to a sea. A child fills a cup from a garden hose and discovers by accident that the tap water now tastes like a fizzy soft drink. That is the cruel irony of this hypothetical. The trigger is something humans love. Carbonation, seltzer, sparkling water. We've been adding fizz to our drinks for centuries because it feels good in the mouth. And it turns out that the universe, taken in that exact dose, planet-wide, is incompatible with everything alive. It's a reminder that the comfortable Earth we know is balanced on a very thin chemical edge. A small change in one variable, a few grams per liter of dissolved gas, ends everything. Not slowly, not after generations. By dinner, survive the crocolypse? No. But the last few drinks would be amazing.